Okay, so we are moving on to chapter 9. We're going to start out with a super simple lesson. So section 9.1 is broken up into two parts. It's the square root principle and completing the square. We're just going to do the square root principle today. Okay, so hopefully from freshman year you remember that there's 4 different methods to solving quadratics. So that means solving equations that have something squared. So when you had freshman year, you definitely solved by factoring, which we've done a bunch this year. You learned solving by taking the square root, and you learned the quadratic formula. You just haven't learned completing the square, which you will learn in our next lesson. But today, we're just going to refresh your memory on solving by taking the square root. Okay? So, the square root principle says that if I have x squared equals a number, where a is a real number, then you could take the square root and you'll get the square root of positive a and the negative square root of a. Okay, we also write it as plus minus the square root of a. So we're going to have 2 answers. Okay, remember that if you have something squared, that tells you how many answers you're going to have. So I should have 2. So if I had x cubed, I should be getting 3 solutions. If I had x to the 4th, I should be getting 4 solutions. So on and so forth. So we could apply the square root principle when we just have an x squared. There's other methods. Let's say I had x squared and a x and 64. Well, there'd be different methods to solve that. I would probably do that by factoring. Or you could use the quadratic formula, or you could use completing the square. But we generally use the square root principle when you just have an x squared and no other x. Does that make sense? Okay, just an x squared, no other x, no other variable. So what you want to do is make sure that your x squared is isolated. And once you have that, you're going to take the square root of both sides, and I'm going to get my 2 answers. So x is either going to equal 8, or it's going to equal negative 8, or to save yourself some time, you could write your answer as plus minus 8. Okay? Number 2. My x squared is isolated, so I'm going to take the square root of both sides. So I have x equals plus minus the square root of 50. However, I can't leave my answer like this. I have to simplify. So I'm going to break this up into a perfect square and non-perfect square. So I'm going to take the square root of 25, which is 5. And then I have root 2 left. So x equals positive 5 root 2 and negative 5 root 2. Okay, you can write those as 2 separate answers, or you can write it with a plus minus. I do not care. Okay, number 3. I'm ready to take the square root of both sides. So x equals, I get, so since 100 is negative, let's go back to our complex numbers and our imaginary numbers, right? We do have an answer for this now. So we could write this as plus minus 10i, or you could write it as 10i and negative 10i, but we are going to apply our imaginary numbers into our solutions now, because before in freshman year we would say this was not real. Well, now we know that this is actually equal to an imaginary number, which in this case is 10i. Okay, let's talk about again why that is, because this is actually saying the square root of negative 1 times the square root of 100. Well, we know the square root of 100 is 10, and the square root of negative 1 is I. Okay, that is why it is 10i. So in number 4, when I take the square root, again, I have a negative number, so I know it's going to be somewhat imaginary. So I have x equals plus minus. That's giving me my 2 answers. And then let's break this up. I'm already going to take out that negative 1, and I'm going to put the I out in front. And I'm going to make this just the square root of 40. Okay, and then I have to simplify the square root of 40. So I'm going to break it up into perfect squares. So I have 4 and 10. I think that's the biggest one. There's no perfect square that goes into 10. So I'm going to take the square root of 4, and I'm going to bring that out. So plus minus 2i, because the I is already out there, square root of 10, that's your 2 solutions. So positive 2i square root of 10 and negative 2i square root of 10. Okay? So again, apply your knowledge about imaginary numbers. So in number 5, before I could take the square root of both sides, you have to isolate your x squared. You have to get it all by itself. So what I'm going to do is I'm going to move this 6 over. So I get x squared equals 48. And then I'm going to take the square root of both sides. So x equals plus minus the square root of 48, but we have to simplify that. So the biggest perfect square that goes into 48 is 16. So the square root of 16 is 4, so plus minus 4 root 3 is my final answer. Okay, number 6. So I need to get rid of this 11 to get the x squared by itself. And then I got to divide by 2. So x squared equals 27. Okay, take the square root of both sides now that x squared is by itself. So x equals plus minus the square root of 27, and then make sure you're fully simplifying. So 9 and 3, square root of 9 is 3, root 3. Okay, again, make sure you have the positive and the negative. There's always 2 answers unless it's, no, it's just always 2 answers. Okay, so number 7. So now I have a binomial being squared. So whatever is being squared, make sure that's what you're isolating. That's what you're getting by itself. And then we're going to do the same exact process. So I'm going to take the square root of both sides. Remember, when you take the square root of anything squared, it cancels out the square and you're just left with what's in the parentheses. So I get x plus 6 equals 7. Okay. It actually equals plus minus 7. So this is going to be x plus 6 equals 7, x plus 6 equals negative 7, and I'm going to solve both of those equations. So x equals 1, and x equals negative 13. Okay, it's good to check both of those. So if I plugged in negative 13 to the original equation, I would get negative 13 plus 6, which is negative 7. Negative 7 squared is 49. Okay, and you would get the same thing with positive 1. Okay, so both of those would be my answers. Okay, number 8. So whatever squared is isolated, so I'm going to take the square root of both sides. So this becomes 5x minus 1 equals 10, and it also equals negative 10. Let me just write it as 2 separate equations in this one. I'm going to solve both of those. So 5x equals 11, so x equals 11 fifths. 5x equals negative 9, so x equals negative 9 fifths. Okay, and then those would be your 2 answers. And then lastly, number 9. So take the square root of both sides. So I get 8x plus 6 equals plus minus the square root of plus minus I, the square root of 32, but let's simplify this first before we solve for x. Okay, so I could break this up into 16 and 2. So I get 8x plus 6 equals plus minus 4I root 2. Okay, then I have to subtract 6 from both sides. So if it makes it easier, if you don't like the plus minus, just separate it into 2 equations. So 8x plus 6 equals positive 4I root 2, and 8x plus 6 equals negative 4I root 2. Okay, and then I need to isolate x. So for both of them, I'm going to subtract 6 from both sides. Now I can't combine the 6 with those. You just have to write it as negative 6 plus 4I root 2. And this one's going to be negative 6 minus 4I root 2. Okay, and then you're going to divide by 8. So I get x equals negative 6 plus 4i root 2 over 8. And x equals negative 6 minus 4i root 2 over 8. Okay, so if you want to write this as one answer, you can. So negative 6, you could have kept it like this the whole time with the plus minus. It's saying the same exact thing, but also make sure you're fully simplified. So notice that all of these have 2 in common, so you could simplify these by dividing everything by 2. So my final answer is actually negative 3 plus minus 2i root 2 over 4. Okay, I recommend keeping it as a plus minus so it's a little bit less work. And then also keep your eye out for the fully simplifying your answer.